You have probably already heard about augmented and extended realities. This is a truly marvelous way to bring digital products into the physical world and to present to clients. What's the first thing that comes to your mind when you think about AR and XR? It's probably recent Apple Vision Pro or Microsoft HoloLens. All these products are quite expensive. But what if I tell you there is a super alternative to it, and it's right in your pocket? Yes, I'm talking about your phone. All you need to bring digital designs to the physical world is a Hologram app. And today I'll show you how. I will show you the use of Hologram on the project we did a few years ago, which is parametric bar counter. It's basically bar counters consisting of acrylic rods. Each rod has different lengths and follow the attractor or noise pattern. We specified several groups of rod lengths, so it's easier to fabricate, and provided a special placement map for the design, so they could assemble it in place. Everything was done with Grasshopper, and today I'm going to use this project to demonstrate the possibilities of the Hologram. And the first thing we should do is to install the Hologram on your device. Go to the App Store or Google Play and download the Hologram app. After that, let's go to the Hologram website, navigate to the dashboard, and create an account. After you did this, you can start your trial period. This video is sponsored by Hologram. Using the promo code INGENERIC, you'll be able to get 25% off for the Hologram subscription. Also, visit our Instagram and our website to find out more about our parametric courses and parametric design market. Once you registered your account and linked your device to it, we can now switch to the Rhino and Grasshopper. And the first thing we do here is installing the Hologram plugin. We can go to the package manager, search for the Hologram app and click install. After that, restart your Rhino and Grasshopper. After restarting the programs, you should have the Hologram tab in Grasshopper, and when you type Hologram and Rhino, the Hologram panel should appear. I'll close it for now. And let's switch to Grasshopper to start modeling. And we shall start with a simple rectangle. Let's specify the dimensions. I'm working in millimeters, so it's gonna be 1.5 meters in X direction. And let's do another slider for the Y direction. After that, I will remove the back wall of the counter. Let's do explode and cool index, and we will remove index number 2. I'll hide every component I don't need to see. And after that, I'll join the curves back, and we'll fill it the corners. With a certain radius. Let's say 200 millimeters. Should do. Great. It's a base curve for the bar counter. After fill it, I'll put the fit curve component. With the degree 3. to make the curve continuous. And after fit curve, I can extrude the base curve to the certain height in that direction. Let's say 1.1 meter. Should be fine. Great. The base is ready. Now we need to split it into points. I'll go into the Surface tab. And we'll get Divide Surface component connected to the extruded surface. And I'll need to distribute these points with a certain distance. So I need to understand how many points I need in U and V direction of the surface. This I'll do using just simple division. First, I will divide the length of the base, of the base curve. Say this one, to a value of the spacing between rods, let's say 50 millimeters. Let's connect, and then I will divide the height in the same way. I will divide the height value to the same 50 millimeters. Let's connect one to U and one to V. And we will get a proper grid of points on the surface. Perfect. By the way, this extrusion component is going to be the base wall of the geometry. Let's make a custom preview. And the color swatch with the dark, let's say dark gray or black color as a background. Great. I will select all these components and we'll create a group out of them because this is an initial geometry. Let's place it nicely. Okay. Then we continue to work with Divide Surface component. As you can see, we have points on the very edge of the surface, and we definitely don't need them because there are going to be no rods on the edge of the surface. And this is what I'm going to do. I'm going to remove them completely. Okay, in Divide Surface component, I have a lot of tree branches. And I'm going to remove first and last element in every branch. I'll use CoolIndex to do that. And I will cool two points in every branch, one with index 0 and one with index -1, meaning the last point in every branch. Turn off this preview and you can see there are no points on left and right edges, on the vertical ones, right? But I still have points on top and bottom, meaning I need to remove the first and last branches from the tree. I'm going to do it in the same manner. I will use tree statistics to get all the passes, and from the passes I will delete first and last one. And after I did that, I'm going to select every tree branch that left. Okay, again, I will turn off every other preview. Great, now we don't have unnecessary points on the edges, and that's amazing. Now we shall do approximately the same thing with the normals of every point. Since we need to extrude the rods in the normal direction to the surface, I shall remove the very same normals. We're gonna do the same but a little bit differently. Since we already have the necessary paths, I'll just copy this component, the tree branch, connect it to the normals, and yeah, I'll do simplify here and here. And here. Okay. Now I have the same tree branch indexes for both points and normals. Great. And last but not least, I'll copy the cool index component and will remove first and last from the normal tree branch, since we haven't done it before. Okay. I think this is done. Let's group these points. Perfect. Now let's add lines. We're going to use lines SDL, meaning start, direction, and length. As a start, we're using all the points. As a direction, all the vectors. And for the length, let's put some value for now. Let's say 100 millimeters. Okay, what I see now, for me, they're extruding inside the surface. That's not perfect. And what I need to do, I need to make all the vectors opposite. So I'll just use negative component to switch the direction of every vector we have. Great. Now roads are good. Let's add some pattern to it. You can use whatever you want. You can do attractors, or we can use some noise. Let's add some noise. I'm going to use the noise 4D component, which is called Simplex Noise. It's a separate plugin. You can use one from Noise 4D, or you can use one from GitHub Terra. It's called Simplex Noise as well. Yep, the principle is the same. You provide points to each component. For the Simplex Noise from Noise 4D, you just put points. For the GitHub Terra one, you should deconstruct the points before. And everything else works the same. Okay, I'll stick to Simplex Noise, since I don't need any other components to use with it. I'm going to remap all the numbers from Simplex Noise using remap numbers component and bounds component. Here we go. After that, let's have a graph mapper with a Bezier spline. Something like that. And after the graph mapper, again, the remap into the real lengths. I'm going to use the domain between 50 and 200 millimeters. 50 is for shortest road and 200 for the longest one. Okay, and right now we can connect it right to the line SDL. I can already see the difference. And all I need to do here is to adjust the scale of the pattern of this noise. It probably has to be something really small for the simplex noise. Okay, something like this. Great, but there is one problem. Right now, every rod has its own value of the length, and every rod appears to be unique and has this weird value of length. We need to change that. We need to specify several groups of lengths. We need to standardize the production. So let's do it. We need to create several groups of lengths and specify the standard lengths to every rod. Let's create a group out of these nodes, and I will use the construct domain, this very domain, and we will divide it into several groups using divide domain component. Let's use 10 groups for now. We can change it later. Okay, after that we need to check in which domain the length of the rod falls. So we use include component, connect the remap numbers and divide them. Okay, let's now check what we've got in includes. I see. We'll need to do one more thing. We need to graph this input in order to check every value against every domain from divide domain component. Right now we have just one true value in the branch. Perfect. Let's find out the index of this true value. To do this, I'm going to use member index component. Like this. And I'm going to search for the true value. And we'll add a Boolean placeholder to make sure that data in sets and in the member input are the same. And they have the same data type. Okay, let's check. We've got indexes. Perfect. But it's still not what we need. Still, we have these weird values, which we need to round up. And that's what we're gonna do now. We're gonna create a specified length for every rod group. I'm going to do it using a range component. For the domain, we're using existing one, which we did before. And for this number of steps, I'm going to use the count slider, but with one change. I'm going to use expression x minus 1 because range gives us one more value and then we provide it with. Okay, it's good. Right now, let's divide these numbers from range by, let's say, 5. 5 is the value we can round to. So first I'm going to divide every value by 5. Like this. And then I'll use an integer. Integer node to round all the values in the division. And after the integer node, I'm using multiplication. And I multiply this round value from integer to the value I'm rounding to. In this way, with this simple code, I'm getting proper values which fall within the given range. After that, we can change the division number or the rounding number from 5 to 10, for example. And now let's use the list item in order to select the proper lengths for every rod. As index, we provide member index, and as list, a list from multiplication. Okay, great. Right now, I'll use panel to see what's happening. Okay, I will simplify this tree and we'll use dream tree component in order to simplify it even more. And now I can use it with line SDL. Great. We've got the proper lengths for every rod we have. Okay, now let's go to the Follogram tab and we will select a very useful component which called the mesh pipe. Mesh pipe will give the volume to our rods. So we connect the lines and we connect the radius. Let's say 50. No, 50 is too much. I'll probably go with just 10 millimeters. Great. And I increase the number of sides to make them more roundish. Let's say 8 sides or 2. Great. And the last but not least thing, I'm going to cap all the rods. Right click on the cap input, invert it, and I have a proper mesh rods geometry. Perfect. Right now I want to color the rods according to their lengths. For this I'm going to use allocate by index component from GitHub Terra plugin. I make flatten on the BI input and I connect output of list item to it. Perfect. Let's move it closer to the rods. I flatten this D0 and connect the mesh pipe. Amazing. Now I have a proper data structure with several branches. And you can see the branch index 50 means this branch contains rods with 50 millimeters length and so on. Okay. Now I'm going to create colors. I'm going to use tree statistics component. And let's connect tree statistics to the allocate by index. And the output count I'm going to connect to the color wheel. Let's connect them. I will adjust a little bit the color range, saturation, and the luminosity. Something like this will work. And then I'm going to use custom preview component from the display tab. I will grab the color input and connect the actual geometry. Okay, here we go. We have colored our rods according to their lengths. Perfect, great. Right now, let's add our geometry to the XR so we can preview it in the real world. I'm navigating to the back wall, which is black, and I'm going to the Follogram tab and select the Sync Geometry component. This component is what we need to use in order to put any geometry into the XR. Let's connect the extrude to the geometry. And to preview it with material, I'll connect the color swatch I have already to the material input. Now I can turn off the custom preview. I don't need it anymore. Great. Now we'll be able to see it right in the Hologram app. Okay, there are some other inputs in the Sync Geometry component. And for example, you can change the display mode. Right click on the display input. And by default, it's going to be rendered, which is great for us. And let's leave it as it is. Also, there is an interaction. It's a way you can interact with the object in extended reality. So you can say you can move it, you can rotate it, you can scale it. But right now we're going to use the select option. Select is needed to be able to interact with it in the way that we're going to do. We're going to place some attractors on the geometry right in the real world. So let's use select option. I'll turn off the points and okay, let's work with the rods right now. We do exactly the same. We're using Sync Geometry component. We connect the geometry, the rods. We do graft on the material input and connect the colors. Turn off the preview of the custom preview component. And that's pretty much it for the rods. On this stage, you can already use Hologram with these components we just did. So let's go to the command prompt and type Hologram. The pop-up window will appear, and all we need to do is press connect, turn on the Hologram on your phone, and scan the QR code. And you'll be able to place this geometry right in the real world. But there is a small problem, you won't be able to control its position. It will not be precise and probably the scale of it might vary. But the good thing is using Hologram, you'll be able to place it correctly because you can use XR markers. And let's place them right now. I'm typing in the command prompt XR marker, and I select the location of the mark. I'll put it somewhere in the start of the coordinates, in the 0 point. And for the label, I'll use just 0. It's going to be marker 0. Press enter. Okay, here's the marker. With one marker, you'll be able to place the geometry in the proper position, in the proper point, but you won't be able to control its rotation and scale precisely. So we need to do the second marker. We do exactly the same. I place it at the known distance. And I say it's going to be marker 1. Here we go. Now I have 2 markers. Okay, we have them in the 3D model, and we need to have them in the real world. To do this, we need to print them. Let's enter the XR marker command once again. But this time, we click on Print All button. The Hologram window will appear, and here we see our marker, and just press print. It will open the printing dialog window and just print them like this. You should measure the distance right from this point, because this is the point which you specified in your Rhino file. Once you're done with printing, we can call the hologram window once again. Press connect. The QR code will appear on the screen. Synchronize your phone hologram app with this QR code. And then scan each of the QR codes on your floor or wall or wherever you put it. Now let's add some interaction to the model. We are going to use attractors in the real world. For this, I'm going to the hologram, get pointers. This component allows you to interact with the screen of your phone. So it basically detects where you point on the screen and show this point on the model. So the event is going to be tap. We're going to tap on the screen and we will receive the point on the model. We need to deconstruct these pointers. Like this. Let's use a point component for the target point. Great, the target point is the point on the model. Okay, and right now I'm going to use the data recorder, but not the Grasshopper one, but the one from Sasquatch plugin. Yep, this one. Okay, locate it in the Sasquatch. And it has additional inputs, which allows you to control the data recorder very precisely. So for example, for the first input, which is record, we specify the Boolean toggle, which is going to set true. Then for the reset, it's going to be just button. Okay. And record first data on reset. We will say false to avoid unnecessary points on the model. Okay, great. Now, let's rename this button. Let's call it clean attractors. Why are we renaming it? Because we're gonna put it right in your hologram app on the phone. Let's select Things XR parameters. And we will press a small icon on the left. Okay, now this button is our application. That's amazing. We can control it right from the phone and press this button right on the phone. Okay. Now we're gonna cool some points. Let's use cool duplicates with a threshold something about 10 millimeters. So we don't want to have a repetition for the points And now we're finding the closest point on the surface to ensure that all the points are exactly on the surface. We're using the extrude we did before. And after all the points are on the surface, we're going to use pull point component. The points from BREP are going to the geometry. And the other points are going from tree branch we did before. Let's flatten the input. Okay, right now I want to connect it instead of simplex noise, but I'm going to create a switch. And the switch between these two states, attractor or noise. Let's use stream gate. In input 1, I'll connect the distances from the pull point. And for input 0, the simplex noise. Actually, let's remove the flatten from pull point. Okay, all we need to do is to add a gate. And we're gonna do it using the value list. Here we go. Let's adjust the naming for the values. Value list we also can add to the hologram map. Right click and let's rename these values. The first one is going to be noise, and the second one I'll call attractors. Okay, let's connect it to the gate. And now we can switch between them. I'll reconnect everything to remap numbers and bound. It works greatly. Cool. Okay, right now let's add also the divide count. Let's rename it and add to the hologram map. Let's call it something like len count. Now I'm going back to the extended reality. And here I just tap on the screen to add attractors to the geometry. Let's add a few of them. Every time I tap on the screen, the geometry changes. Perfect. Now let's change number of steps of the rod length. I can add more or less, and we'll see how the geometry reacts. In order to assemble this geometry, these roads correctly, we need to provide some kind of matrix or letter numbering for each hole. So let's go to the set sequence and we will create a char sequence component. So this component provides you with a sequence of chars, obviously. We will connect the count from tree statistics and we are going to select the proper char for each road using list item. Let's connect it directly to the trim tree. Now we'll have a proper data structure. Cool. I'm going to use construct text dot from Follogram. I'll provide the text as a chars, the points from the tree branch, the size is going to be something around 20. Okay, we can't really see it in preview right now. And in order to make these letters visible in the XR space, let's use a text.placeholder. And the sync geometry component. Okay, now everything is visible in the XR space when you connect your phone. But there is one more thing, we need to switch between modes. We need to switch between showing the roads and showing the letters for each road. And there is such a component which called state gate. Let's use it. I'll also create a value list as a gate. Let's modify it a little bit and rename it to representation. And for the values, I'll have roads and I'll have metrics. Okay. Let's connect false to the sync geometry and true to the roads. I've forgotten to use Boolean placeholder in between. Yeah. That looks better. So now I can preview roads. And what about metrics? It's disconnected. Okay, I'll connect it back. And now I can perfectly switch between these two states. I'll also add this value list to the Follogram so I can control it directly from the phone. Okay, perfect. Now I know exactly where to place every type of the roads. That's pretty much it with the geometry. Enjoy the extended reality. As you can see, the possibilities of Follogram are quite huge, and I'm sure you'll be able to apply it to your work process. Don't forget about the promo code for the 25% off, and Don't forget to subscribe.